In this section, we will see the steps of AI model development. We will understand what is data and the process of data collection. We will understand what is noisy data and the data cleaning process. We will understand the topic of picking a model to solve a given task. We will understand model training as well as evaluation of the performance of the model. We will understand the concept of parameter tuning of the model if we want to improve the model performance. Then we will see model deployment, which is to make the trained model available for everybody in the organization or general public to use. Let's pick a real-world problem to understand the process of AI model development. Let's say we are given the task of developing a language translation system that translates any given sentence in English to a sentence in Spanish. So the end goal is to develop an AI system that takes an English sentence as input and generates a Spanish sentence that is the translation to the input sentence. So the first task is to collect a lot of data. The data in our case is translation pairs of sentences. So we need to collect lots of pairs of English sentences along with their Spanish translation pairs. It is ideal to see if such translation pairs are already available online. There is a possibility that someone else had a similar requirement and created these sentence pairs and made them available online. This is called a dataset. So essentially we look online to see if the dataset that we want to use is already available online. If so, we use it directly and do further cleaning if necessary to modify the data to our needs. But let's say you are building a language translation system specifically for hospital medical records text. Then you need to create the dataset yourself. What this means is that we need to employ experienced medical translators and have a system or process in place where they can easily convert a given sentence in English to a sentence in Spanish. Also, we need to execute it at scale, because if we need tens and thousands of translations to train our model, it is not practically possible to do with a handful of translators. Hence, there are separate tools developed just for data annotations, and some companies are built to provide just data annotation or data creation services. Depending on the task at hand, organizations can choose to have a small in-house data annotation team or outsource the data creation task to a third-party vendor. Also, the quality of any AI model is just as good as the data it is trained on. So it is very important to have a quality control process to remove noisy data that is, in our case, low-quality translations. This is the data cleaning process. One way is to have a quality control team where multiple people independently rate the quality of a given translation, and later we only source the highest rated translation pairs for our AI model training. In this way, we can ensure that we have high-quality data and we are ready for the next step. Now that we have our data ready for training, let's discuss choosing a model to train your data on. A model is analogous to a brain. Just like different brains have different learning, memorizing, and recalling capabilities, similarly, different models have different capabilities. For example, let's assume you are a manager and you have a new project requirement and need to hire a new member to the team. You are debating whether you should hire a junior engineer or a senior engineer to learn and execute the project. While the junior engineer might not be accurate at performing a given task because of lack of experience, he or she is very economical. While the senior engineer might be very accurate, they might be expensive. A model has a lot of parameters that will be trained. As the parameters are just decimal numbers or integers, the size of the parameters determines the size of the model in megabytes or gigabytes when it is stored on disk. So in reality, choosing an AI model for a given task is finding the perfect balance between model size, the speed with which it generates an output given some input, the accuracy of the model, and ease of maintenance by other developers to retrain when necessary. Now that we have picked a model and also prepared the training data, the next step is to train the model. Training a model means showing data in batches to the AI model and making it learn. For example, in our case, if we have 10,000 translations, we group them in batches and show 64 or 128 translations at once for the model to learn. Since we already know what is the expected output translation, which is also known as ground truth, every time the model makes a mistake in its translation, we provide a mechanism for it to automatically update its internal weights. This makes the model get better over time as we show more and more samples and correct continuously when it makes a mistake. At the end of the day, text and images are represented as numbers before they are fed into the deep learning model. So a computer only sees a series of numbers and learns patterns from it. Just like students need to revise the curriculum and go through the content more than once to learn thoroughly, oftentimes AI algorithms also need to see the data more than once. One full run of the AI model through the complete dataset is called an epoch. We train our AI model through multiple epochs of the dataset so that it learns better. Well, we finally trained our model and are ready for evaluation. But what is evaluation? Just like we teach a kid during classroom sessions and later evaluate his or her performance in a test or quiz, we do something similar with AI models. From the complete dataset that we collected earlier during training, we set aside a portion of the dataset, usually 15 to 20%, to evaluate the model's performance once it is finished with training. This is also known as a validation dataset or test dataset, and we report our model performance metrics on this validation or test dataset. But what are these performance metrics? Let's take a simple case where you trained an image classification model that classifies a given image as a dog or a cat. You reserved 100 images in total as a test dataset that has 50 dog images and 50 cat images to evaluate the model's performance. Now, when you run your test dataset through the trained AI model, you realize that 5 cat images are misclassified as dogs and similarly 5 dog images are misclassified as cats. So out of 100 images, 10 images are misclassified, so you can say that the accuracy is 90%. But there is a small problem here. Let's say our test dataset has 100 images just like before, but this time we have 95 dog images and 5 cat images. Even if our model blindly classifies every image as a dog all the time, it is 95% accurate. This doesn't sound good. So accuracy is a good measure only if we have an almost equal distribution of classes. Otherwise, accuracy is not a good measure when we have an imbalanced dataset, like in our case where 95% of our test dataset is just dogs. Precision and recall are better measures than accuracy. To understand precision and recall in simple terms, let's take an example where we have 100 images with 95 dogs and 5 cats. We pass the images through our trained image classification AI algorithm, and it classifies 93 out of 95 dogs as dogs and misclassifies the remaining 2. Similarly, it classifies 2 out of 5 cats as cats and misclassifies the remaining 3. The precision for dog class is defined as the proportion of images that are classified as dogs are actually dogs. So in our examples, 93 dog images and 3 misclassified cat images are identified as dogs by the AI algorithm. So a total of 96 images are classified as dog images, and among them, 93 images are actually dog images. So precision is 93 by 96, which is equal to 0.968. So precision for dog class is 0.968, which also means that when our AI model predicts that an image is of a dog, it is correct 96.8% of the time. Let's calculate precision for the cat class. Out of 4 total images that are classified by our AI model as cats, only 2 are actual cat images. So precision for cat class is 2 by 4, which is 50%. So when our artificial intelligence model predicts that an image is of a cat, it is only correct 50% of the time. Similarly, recall for dog class is defined as the proportion of dogs in the original test dataset that is classified correctly. So in our example, 93 out of the total 95 dog images are identified correctly. So recall is 93 by 95, which is 0.978. In other words, our AI model correctly identifies 97.8% of all dogs. Similarly, recall for cats is the percentage of cats in the original dataset that are classified correctly. In our example, 2 out of total 5 cats are identified correctly as cats. So the recall is 0.4. In other words, our AI model correctly identified 40% of all cats. So evaluating an AI model means getting these numbers like accuracy, precision, and recall for our particular use case, and choosing if our current AI model meets the criteria. If not, we go back to the drawing board and see if we need to use a different AI model for training, etc. Now that we have seen how to evaluate an AI model, let's understand the parameter tuning of a model. If we give a big textbook to a student and ask him or her to learn it in 2 weeks, they might be able to only skim through the chapters. When we put them through a test or quiz at the end of 2 weeks, they might perform very poorly due to lack of time. Similarly, the learning rate of a deep learning algorithm can be controlled. So after evaluation, if the trained model is not very accurate, we can play with a better learning rate and see if the performance improves. Unlike the real-world example, we can also play around with the architecture of the neural network a bit by increasing the layers or decreasing them to see if the performance improves. We also show our samples in batches as mentioned previously, for example, 64 or 128, etc. The batch size can also be modified to alter the performance of the model. So these parameters like learning rate, batch size, etc. are called the hyperparameters of the model. These hyperparameters can be further tuned to improve the accuracy, precision, and recall of the model. And usually many experiments are done by changing the hyperparameters, and the configuration that yields the best performance is finally used. Now that we have finished parameter tuning and retraining of our AI model, we are ready for our model deployment. What exactly is model deployment? So far, an AI engineer would have been developing and training the AI model in his or her personal computer or a machine available on the cloud. Once the AI model performance is satisfactory, it is time for the AI model to be available for use by everybody. In our example, once the language translation model yields good results, we want it to be available for use to the general public or to the whole organization that we are working in. So the goal is to make available or deploy the model in the cloud so that a larger group of people can use it. For example, the translation model can be used by thousands or millions of simultaneous users. Sometimes the demand might be less, and at other times the demand could be more. So the system should also scale dynamically to accommodate the number of users using it. A good deployment infrastructure should make sure that a system is highly available and scalable. Top software companies provide tools and services to facilitate the same. For example, Amazon provides a suite of services known as Amazon Web Services or AWS, which one can use to deploy the model on the cloud and scale as necessary. Similarly, Google offers Google Cloud Platform, and Microsoft offers Azure. There are also several other companies providing tools and services to deploy an AI model to production. The subfield of AI that focuses on deploying, managing, and scaling AI models in production is called MLOps or Machine Learning Operations. Outside of artificial intelligence, this field is also known as DevOps, Development and Operations. It is the combination of tools and practices to deploy applications fast and make them available at scale to the end users. In this video, we have gone over the concepts of model deployment and what it means to make an AI model available for hundreds and thousands of users.